Hello everyone, this is part 3 of all IGCSE vector questions. In this video, I will be solving all the IGCSE vector questions in 2023. The first one is question number 16 of paper 058021 May-June 2023. Find the magnitude of the vector minus 4 against 5, that is x equals to 4, y is equals to 5. As you already know that the magnitude will be the square root of square of x add square of y. Therefore, the magnitude of this vector will be square root minus 4 squared add 5 squared. So if you do this, you will get, this will give you square root of 16 plus 25. It will give you square root of 41, and that will be 6.40. And you could as well input this into your calculator and get your answer straight away. Let's go to part B. The diagram shows a triangle OAC. A is the midpoint of the straight line OB. So if A is the midpoint, that means vectors OA and AB are equal. So this will also be x. That will be the value of vector AB. OA is equals to x and OC is equals to y. Find the vector CB in terms of x and y. So the vector CB will be CB equals to CA plus AB. Then let's substitute the values. AB is equals to x. So and CA is the vector CO plus vector OA. So let's find CA. CA will be equals to CO, that is minus y, then plus OA, that is x. Okay, so this is vector CA, the addition of this one, CO, add OA, then plus vector AB is x. So we can simplify this. This will be minus y plus 2x, which you can rewrite as 2x minus y. That will be the vector CB, 2x minus y. So let's go to the next question. That will be question 9 of paper 058022 May-June 2023. We are given vector f. Okay, f is the point 1, negative 4. Fg is vector 8 minus 3. And GH is minus 12, 35. Find 3FG. So 3FG will be equals to 3 into bracket 8 into minus 3. And this will be equals to 3 times 8, 24. 3 times negative 3, that will be negative 9. So you have 24 against negative 9. Then find FG plus GH. This is FG, that is 8 negative 3, add, then GH is negative 12 against 35. So if you add this to this, 8 add 12, the 8 add negative 12, that will be negative 4, and minus 3 add 35, that will be 32. So you have negative 4 against 32. Then part C, the coordinate of the point G. So to get the coordinate of point G, so this is what you need to do. So let's say this is vector F. Okay, so vector F is coming from, let's say, point O, for instance. So it will be 1 step to the right and 4 downward. So this will be somewhere here. Okay, so I can draw a line from O to this place Okay, so that will be vector f in towards this direction. So I can say f is here. So let's scroll down a little bit. Then we are giving vector fg to be 8 minus 3. So that means from f, so you go to the right 8 times and downward 3 times. So it continues like this. So vector g, point G will be here. So that means we can join this to this like this on a straight line. So they'll be going towards the same direction. Okay, so we want to get the coordinate of point G. So once we can get vector OG, okay, so it will make the work easier for us. Then we can easily get the coordinates of point G right away. So from here, OG will be equals to OF plus FG. Okay, so we can key in the values. We know that OF is this 1 against -4 as a column vector, plus FG is 8 minus 3. So if you add them together, 1 add 8, that will be 9. Then minus 4 add minus 3, that will be -7. Okay, so the coordinate of point G will be x equals to 9, y equals to -7. Then part D, the magnitude of vector GH. Okay, so it will be the magnitude of vector GH written like this, be equals to square root of the x and the y values of vector GH respectively. So that will be -12 squared add 35 squared minus 12 squared add 35 squared. So you need to be very careful. This has to be within a bracket. So if you input this, you should get 37 as your answer. Okay, so let's go to the next question. That will be question 12 of paper 058023 May June 2023. Okay, so we only need to solve this question 12. Okay, so we're not interested in question 13. So the position vector of A is this 5 against 3, and BA is equals to 4 against 8. Show that the magnitude of vector OB is equals to 5.1, correct to 1 decimal place. So let's illustrate this. Let's say this is point O. Okay, so the position vector of A will be moving towards this direction. Okay, then we can call that point A. Let's write point A here. Okay, and BA is giving us this. Okay, so that means we have something like this for BA. Okay, so and we can close this one here. So this will be point O, this is point A, and this is point B. Okay, so as you can see, BA is just moving to the right and going up. So it will be towards this direction. So OA is towards this direction. So to get OB from here, so vector OB will be equals to OA plus AB, OA plus AB, like this, OA plus AB. So that will be equals to vector OA is giving us 5, okay, against 3, that is vector A, okay, and we need vector AB, but we don't have vector AB, we only have vector BA, so that will be plus or minus vector BA 4 against 8. So if you do this, it will give you 5 against 3, then minus 4 against 8. So 5 minus 4, that will be 1. So vector OB, okay, will be equals to 1 against then 3 minus 8, that will be negative 5. So we will need to, let's write this is negative 5. Then we need to find the magnitude of this vector. So the magnitude, this is vector OB. Vector OB is equals to this. Then the magnitude now, OB, will be equals to square root of 1 squared plus negative 5 squared. So if you do this, you will get 5.1 correct to 1 decimal place. Okay, so that is how to deal with that question. So let's go to the next question. Question 10. ABC is a triangle. B is the point 1, negative 10. A is the point 4, 14. Then and CA is equals to negative 11 against 8. So let's sketch the triangle. The triangle should be here. This and this. Okay, so this will be the triangle. So let's have point A here, point B here, and point C here. So we are given the coordinates of point A to be 4, 14, and coordinates of B to be 1, negative 10, and we know that CA is equals to negative 11 against 8. So let's write this in x and y component form. So this will be BCA will be equals to negative 11I plus 8J. Okay, then BC. So we don't know the coordinate of C. So let's put x against y. So in this case, this will be BC or CB will be CB will be equals to 1 minus xi, then plus 10 minus 10 minus yj. Then for AB it will be 3i, that is 4 minus 1, that will be 3i plus 14 minus 10, that will be 24j. Okay, so we know that vector CA, let's write here, vector CA is equals to CB plus BA. So let's key in the values. CA will be negative 11i plus 8j, then equals to CB, you have 1 minus xi, then plus minus 10 minus yj, then plus BA 3i plus 24j. So let's expand each of these brackets. We have minus 11i plus 8j to be equals to, this will give us 1 minus x, then plus, okay, let's collect the like times, that's the I and the j respectively. 1 minus x plus 3, everything into I, okay, then plus minus 10 minus y, then plus 24, everything into j. So we can simplify this further. Minus 11i plus 8j equals to 1 add 3, that will be 4. So you have 4 minus x into I plus minus 10 plus 24, that will give you plus 14. So you have minus 14. So you have 14 minus y. Okay, 14 minus y into j. So by comparison, if you compare the vectors, you see that 4 minus x equals to negative 11. So I can solve here. 4 minus 11 equals to 4 minus x rather. 4 minus x equals to negative 11. Then if you collect like times, you see that 4 plus 11 equals to x. So that implies that x equals to 15. I can put 15 here. So also you can compare the j with the j by the left hand side. So this will be 14 minus y equals to 8. So let's write here 14 minus y is equals to 8. Then that means 14. Okay, what you can do here, okay, you can say 14 minus 8 is equals to y. Okay, that means 6 is equals to y is equals to 6. Okay, so that is vector BA. Then let's go to Roman 3. Find the magnitude of CA. So where is vector CA? This is vector CA minus 11 against 8. So it will be square root of negative 11 squared. Then add 8 squared. So if you input this into your calculator, okay, you should get the answer as 13.6. So that will be the magnitude of vector CA, 13.6. Okay, so if you have any other method you could use to solve this question 10A Roman figure 1, okay, so you can comment on the comment section below this video. That will be well appreciated. Okay, so let's go to the next question. So that will be this question. Okay, it's from paper 058041 October November 2023. OMN is a triangle. OM is equals to A and ON is equals to B. R is the point on MN such that MR ratio RN equals to 3:2. MR, that is this one, ratio RN, so this is 3:2. Okay, so we can easily get the values of MR and RN respectively. Since we know that MN, we can get MN here to be equals to MN will be MO add ON. Okay, so it's always good to have the sides, okay, on ground. It helps a lot. So MN is opposite to OM, so that will be minus A. Okay, so OM is A, so MO will be negative A. Then plus ON is B, you have B, so you can write it as B minus A. So that is vector MN. So since vector MN is B minus A, so from here you can get vectors MR and RN respectively. So let's write it up here. So you can say MR will be equals to the ratio of MR, which is 3 over total ratio 5 multiplied by vector MN, that's the total length, so it will be B minus A. Okay, so that is vector MR. So vector RN will be equals to the ratio of RN, which is 2 over total ratio 5 multiplied by B minus A. So it's always good to do this, it helps a lot. Then ORT is a straight line, as you can see here. Show that OR is equals to 2 over 5A plus 3 over 5B. Okay, so that is pretty easy. Okay, so let's do this. So we start with OR. Vector OR is equals to ON plus NR. So I can write vector OR to be equals to ON plus NR. So that will be equals to ON is B, then NR is this. We just found that, and we have Rn to be 2 over 5 into B minus A. So NR will be opposite to this, so that will be a negative sign, so it will be minus 2 over 5 into B minus A. So this is what you get here. So if you expand this now, you get B minus 2 over 5B, then plus 2 over 5A. So this and this are similar, so you can subtract 2 over 5B from B. So that will leave you with 3 over 5B plus 2 over 5A. So you can write this as 2 over 5A plus 3 over 5B. Okay, so that will be the answer, and we have shown that already. So Roman figure 2, NT is equals to 4A plus KB, and OT is equals to COR. Find the value of K and the value of C. Okay, so to do this, we already know that MN is equals to B minus A. If you check here, so MN equals to B minus A. So let's write that. So MN equals to B minus A. Okay, and we already know that OR is equals to 2 over 5A, then plus 3 over 5B. So this is given. Also, NT is giving us 4A plus KB. Okay, so but OT is equals to ON plus NT. So let's write this down. So OT is equals to ON plus NT. Okay, that means we can write OT to be this now. OT now be equals to ON is B plus NT is equals to this 4A plus KB. So we can call this equation 1. Okay, so also we are given that OT, let's come up here, OT is equals to C multiplied by vector OR. We are given from here. Okay, so we already know the vector OR to be equals to this. Okay, so that means OT once again will be equals to C into bracket vector OR, which is this. So we have 2 over 5 into A, then plus 3 over 5 into B. Okay, so let's expand this. Okay, let's call this equation 2. Okay, so if you equate equations 1 and 2, so you see that B plus equation 1, that is B plus 4A plus KB, will be equals to equation 2. So I'm going to expand the bracket 2 over 5 or 2C over 5A, because I want it to be in form of A and B, then plus 3C over 5B. Okay, so let's factor out B from the letter side. Okay, so we can have okay, if you bring this closer, B plus KB plus 4A will be equals to this 2C over 5A plus 3C over 5B. So I can factor out B here. So I can say 1 plus K, 1 plus K into B. If you factor out B, then plus 4A. So I can bring 4A to the front. 4A plus this, it will be equals to this 2C over 5A then plus 3c over 5 multiplied by b. By comparison, so 4 will be equals to 2c over 5, as a will cancel out, so you can cross multiply. I'll have 20 to be equals to 2c, and c will be equals to 10. So that's the value of c, it will be equals to 10. Also, by comparison, 3c over 5 will be equals to 1 plus k. So I need to get a space somewhere. Okay, so let's erase this a little bit. So by comparison again, you say that 1 plus k is equals to 3c over 5. So if you cross multiply, it will be 5 into 1 plus k equals to 3c. But we got the value of c to be equals to 10. So we can substitute that. So that will be 5 into 1 plus k equals to 3 times 10. That will be 30. So if I divide both sides by 5, I have 1 plus k to be equals to 6 here. Okay, as 5 goes in 30 6 times, finally k will be equals to 6 minus 1, and the value of k will be equals to 5. So that means k is equals to 5 and c is equals to 10. So let's find the magnitude, the vector mt. So if you go to the diagram, you see that vector mt is this line here, and it will be equals to mo plus on plus nt. Okay, and you could as well take another root. It could be mr plus rt, so you can take that root as well. Okay, so let's write the answer here. mt will be equals to vector mo plus on, then plus nt. So let's key in the values. You have minus a plus b, then plus 4a plus 5b. Okay, so if you simplify 4a minus a, that will give you 3a, then plus 5b plus b, that will give you 6b. So let's write 6b here. So you may want to factor out 3, okay, and you could leave your answer like this. So you have 3a plus 6b. So let's go to the next question. So that will be question 26 of paper 058022, October November 2023. The diagram shows a parallelogram OPQT. The position vector of P is A and the position vector of T is B. K is on PQ, so that, okay, this is point K is on PQ, so that PK ratio QK will be 3:1. So that means this will be 3 and this will be 1. Okay, so I can find their corresponding values once I know the value of PQ. Okay, so let's continue. The lines OK and TQ are extended to meet at point X here. Find the position vector of X in terms of A and B. Give your answer in the simplest form. So the position vector of X will be vector OX. Okay, so we need to get some things here. Okay, so let's start with this one. PQ is the same as OT. Okay, so we can easily find PK and then KQ respectively. Okay, so let's start with PK. So PK will be equals to ratio of PK is 3 over total ratio 5 multiplied by length PQ, that will be B. Okay, so equally KQ, okay, will be equals to ratio of KQ, which is 1 over total ratio. Sorry, this is not 5, this is 4. The total ratio is 3 add 1. Okay, it will be 1 over 4 multiplied by B. Okay, so we know that vector OX will be equals to, you can take this root or this root. So you can take, let's take this one, it will be equals to OT, okay, plus TQ, then TQ, then plus QX. That will be vector OX, which is the position vector of X. Okay, so but OT is B and TQ is A. Okay, because of the opposite sides of a parallelogram are equal. So we need to get QX. Okay, so we have two triangles here, triangle KQX and triangle OTX. Okay, they are similar triangles. Okay, so I can say triangle OTX is equals to triangle KQX. Okay, so from there I can say side QX over side KQ is equals to side TX over side OT. So I can substitute the values. QX over KQ will be equals to 1 over 4B as found up here. Okay, which will be equals to TX. So TX will be equals to TQ plus QX. Okay, because we don't have the direct value for it, then I can write it as TQ is A. So let's remove this TQ. It will be A plus QX, then over OT, which is B. Okay, so from here B can cancel out B here, so I'll be left with QX equals to 1 over 4 multiplied by A plus QX. Okay, so let's scroll down a little bit. So from there I can have QX to be equals to 1 over 4A plus 1 over 4 QX. I can collect like times. I have QX minus 1 over 4 QX to be equals to 1 over 4A. So this will give me 3 over 4 QX to be equals to 1 over 4A. Also 4 will cancel 4 here, so I'm left with okay, let's demarcate this. So I'm left with 3QX to be equals to A, and from here this implies that QX equals to 1 over 3A. That's the value of QX. Then I can now substitute the value into this equation here. Okay, so that is vector OX. So we'll say OX is equals to OT, that is vector B, plus TQ, that is vector that is A rather. Okay, then plus vector QX, that is A over 3. So if you can add these two together, so that will give you B plus, this will be 4 over 3A. Okay, so which you can rewrite as 4 over 3A plus B. So that will be the final answer, 4 over 3A plus B. So let's go to the last question. Okay, so here we are asked to find, okay, let's scroll down. This is not the question. Yes, so this is the question. Question 10 of paper 058023, October, November 2023. We are giving AB to be equals to this. So we have to find the value of 3AB. So 3ab will be equals to 3 into 7 into negative 3. This will be equals to 21 against negative 9. So we have 21 against negative 9. And part B, we have to find the modulus of AB. So the modulus of AB, written as this, will be equals to square root of x squared plus y squared. So x equals to 7 squared, then squared, plus y equals to negative 3 squared. Okay, so if you do this, you get your answer to be 7.62. 7.62. This is the end of the solution to all IGCSE vector questions in the selected years. So if you notice very well, you see more of the questions in papers 2.1, 2.2, and 2.3 respectively. So watch out for another series on another topic.